Well, good morning or good afternoon, everybody. My name is Andrew Braham, and I'd like to welcome you to this Pavinar, where we will be talking about an overview of Warm Mix Asphalt. To start with some basic logistics, those of you who have joined us before have seen this, but if you cannot hear me talking right now, please check your computer volume and or speakers, and if you are in the Illuminate software, you can also go to Tools, Audio Setup Wizard, and then follow those instructions for help. And if you have a question, please raise your virtual hand by clicking on the hand icon below the list of participants. So if everyone looks at the left-hand side of the Illuminate Live software, you can see a list of participants. Directly beneath that list, there's a small hand with a green arrow. If everyone could please try raising their hand, that gives me an idea that you can hear me. All right, we're getting some hands raised. Well, thank you very much. So if you do have a question during the presentation, I encourage you to raise your hand, and I will pause at a convenient break. And immediately below the participant box, you can see a chat box. And when you ask your question, you can simply type that question into the chat box, and I will be able to answer it at that point. Now, you may have noticed that I've taken away all microphone privileges, and that is simply because there's often a lot of background noises in offices, and I can understand that. But we don't want any of that coming over through the presentation. And also, PDH hours will be emailed to you after the presentation. I'll email them to the address you logged in as, so I look forward to that after the presentation, and we will get started. So today we're going to have an overview of Warm Mix Asphalt. You can see here is a picture of a Warm Mix project on the left side of the screen, and then a traditional Hot Mix project on the right side. And one of the advantages of Warm Mix Asphalt is a decrease in those emissions. It's not only visual, but also what we can't see. And this is what we'll talk about today. We'll go over a little bit of background, which has both a usage and overview of Warm Mix Asphalt, and also a list of some of the advantages and disadvantages. We'll cover the different types of Warm Mix technology. There's three general categories with many different products underneath that, including foam, wax, and chemical Warm Mix Asphalt. We'll also go over some field examples, both of highways and at airport, and we'll highlight some of the advantages that they saw from those projects. And then finally, as an academic, I do love the research. We will go over a survey of some free reports that are available online for you if you're interested, and also go over some projects that looked at a cracking of warm mix in the laboratory. Now, I do want to remind you that this is a very broad overview. Some of you may have actually seen some of these slides before, but if you have any specific interests or specific topics that you'd like to hear more about, please feel free to go to the Pavinar website, and you can suggest topics on that form as well. So this map used to be a lot more colorful just a couple years ago. The states that are in blue are the states that have used Warm Mix Asphalt. Now, I spent a little bit of time last week digging through, and I was not able to find any projects in North Dakota that have used Warm Mix Asphalt, but all 49 other states have used a Warm Mix Asphalt, anywhere from a simple trial all the way to a pretty extensive use. So Warm Mix Asphalt is definitely here with us, and it's probably going to be a part of our future. So I think that there's a lot that we can learn and we can go from off of that. Now, just kind of talking about some of the basic concepts of Warm Mix Asphalt and compare that to Hot Mix Asphalt. You can see some general temperature ranges for Hot Mix Asphalt. Production and construction is approximately 135 to 160 degrees Celsius, whereas Warm Mix Asphalt is approximately 30 to 50 degrees Celsius lower. And that's the 95 to 125 degrees Celsius range. And I apologize for the Celsius units. The last time I gave this presentation, I was not in the United States, so I'd converted it all to metric. But double it and add 30 to Celsius is my unofficial rule of thumb. So warm mix asphalt is a general term, and it's called WMA for short. And there are many different technologies. And really those can be broken down into two major categories, either additives or alternative production processes. Now when thinking about warm mix asphalt, these things do not need to be changed when switching from hot mix asphalt to warm mix asphalt production and construction. You can use the same aggregates and asphalt cements. You can use either a continuous or a batch plant. Now if you do use a technology that requires a slight change in your plant, you will need to do that. But all in all, you can use the same equipment for that. And also then on the job site, you can use the same hauling, paving, and compaction equipment as well. So warm mix asphalt usually does something different with the material side of things, and it's usually adding something new. So pretty much everything else you can keep the same. Now here's a long laundry list of advantages and disadvantages. You have your lower production and construction temperatures, and with those lower production and construction temperatures, you get reduction in energy, reduction in emission, reduction in odor, and oxidation. All of these are advantages to those lower temperatures. You can also have a longer haul distance, because if you start out with a cooler mix, it won't drop as quickly as you haul it. And you can extend your paving season. Because of those lower temperatures, it's a little more kinder as the temperature starts dropping. And also, because it doesn't need to cool down as much after placement, you can have a quicker return to traffic. So these are all advantages that are pretty much direct byproducts of the lower production and construction temperatures. Now you also have a decrease in binder viscosity, which means you have easier compaction, and you can also have a higher recycled asphalt pavement content, or RAP content. And then finally, going over to performance. Most projects that I've read about have not seen a decrease in performance. Some have seen an increase. So there's kind of there's some sides to both stories there. And really the only disadvantage I really see at this point is kind of from a specification side. And you may need to add a coating, workability, or compactability element to your specifications. And just recently, a National Cooperative Highway Research Program report has come out addressing some of these issues, and I will show that report later on in the presentation. But these are things that have been recognized in the industry that we may need to pay special attention to. So we'll move from the background of warm mix asphalt to the different types. And at this point, are there any questions? Again, if you do have a question, please raise your electronic hand in the chat box and then type the question, the electronic hand underneath the participant box, and then you can type your question into the chat box. Okay, we got a question from James. I'll wait for you to write the question in. So the question from James is, does warm mix require different testing procedures in the lab from hot mix? And James, that is an excellent question to ask someone in the university, because I think a lot of the tests that we are running now are based on the hot mix asphalt technologies, and we've been just using those tests, and we'll go over a couple those later on in order to compare warm mix to hot mix asphalt. So using maybe the same aggregate and binder source, but one using a warm mix technology and one using traditional hot mix, and just kind of comparing those side by side with current tests. Now, I think that the industry has really gotten excited about warm mix asphalt, and we've seen some examples of projects going down, but now is really the time for academia to start stepping it up and starting to look at questions exactly like that. Are there different tests that should be developed, that could be developed, that are specifically for warm mix asphalt? So a very long answer to your question is, at this point, we don't know if it requires different testing procedures, but that is certainly something we should look into. Are there any other questions at this point? You can raise your electronic hand. All right, well, as I mentioned, if you do have questions, you can feel free to raise your hand during the presentation, and then at a convenient stopping point, I will continue, and we can go on from there. So looking at the different types of warm mix asphalt, there are really three different technologies. The first technology is a foam technology, the second is a wax technology, and the third is a chemical technology. And these are just some examples of existing warm mix technology, and there are many, many more. You could pretty much fill this entire slide with all the different technologies that are out there. But kind of taking a step back and looking at the larger picture, when you're thinking about foaming technologies, that is the addition of water to the system. And as hot mix asphalt people, we tend not to like water. That sets off some warning bells, but if done properly, it can actually add to the process. And we'll go over the mechanisms of the foaming in the next slide. You can also, before I go on, I did want to mention that with the foaming technology, you can either have new equipment, such as the double barrel green system, or you can add pellets that have water in them, like a zeolite, asphalt min, or advera. Those are additives that actually have water encapsulated in them, and then that's how the water is introduced. So there's two different ways you can introduce water. Another type of warm mix asphalt is the wax technologies, and there are three listed there. This is simply where you add a wax in order to reduce those production and construction temperatures. And then finally, there are also chemical processes. A couple listed there. That's where you add some sort of chemical to the asphalt cement in order to get those lower production and construction temperatures. So when we're looking at the different types of warm mix asphalt, we'll first cover the foaming technologies. And as I mentioned, there's two different ways to do this. You can either inject water directly into the liquid asphalt cement, and an example of that is the double green barrel system. And what happens is when you inject this water into the asphalt cement, the water evaporates instantaneously, and that causes the asphalt cement to foam and expand. And after it is expanded, it can then coat the aggregate as it mixes it. The other alternative to the foaming technologies are synthetic zeolites. And this is where you have water trapped in a crystalline structure. The natural form is in a zeolite, but then you simply combine these zeolites with the asphalt cement. So it's just kind of like a wet additive to your asphalt cement. And when that happens, the water that is trapped in the structure evaporates, and that causes the foaming mechanism. Now when you're looking at synthetic zeolites, this is an addition of another product, and it's approximately added at 5 to 6% of the weight of the asphalt binder. Moving on to the wax technologies of warm mix asphalt. Wax additives can either be added dry, which is where you would traditionally treat them as another aggregate, or you can add them wet, which is where you mix them with the binder. And there are considerations both ways, especially if you have a plant. Do you have extra space for a stockpile that's covered, or do you want to add the wax into a binder that will take up an exclusive tank? Those are things that need to be thought about. There are various sizes of these wax pellets. You can either have a prill, which is approximately 5 millimeters in diameter, small prill, which as indicated is smaller than a regular prill. They're approximately 1 millimeter in diameter. And also you can have flaked chips, which are approximately 3 millimeters long, but they're not a circular shape or a spherical shape, but they're more of a flaky shape. Now these are often packaged in bags anywhere from 20 to 600 kilograms. So again, when you're thinking about how you're going to add it into the system, you know, what meets your needs best, what kind of sizes are you needing to add it to, and when you're thinking about how much you'll need, it's generally added at approximately 1.5 to 2% of the weight of the asphalt binder. And kind of talking or segueing into James's question that he asked earlier, during the mix design procedure, you do need to do a new mix design when you're doing these technologies, because especially when you're adding new products, it's always good to redo your mix design to make sure that you're still getting the performance that you're expecting. And the third and final type of warm mix asphalt in these three categories is the chemical variety. And there are two different ways you can do this. You can either insert a chemical, which is often brought in by totes, as seen right there. You can bring in a chemical and add that directly to the asphalt cement. And then we'll be talking about, you know, maybe needing another tank if you're going to be doing this on a regular basis. Or there has been opportunities to also use an emulsion type technology to get those lower production and construction temperatures. And that would involve bringing in a tanker truck of emulsion to your plant and feeding that directly into the hopper. So when those emulsions are, directly into either the drum or the pug nose. And when those emulsions are transported to the plant, they're usually 70% asphalt, 29% water, and then 1% of that chemical. So we've gone over the background, we've gone over some different types, and now we're going to go over a whole bunch of examples of different technologies being used in the field and hopefully highlight some of those advantages that we talked about earlier in the presentation. But at this point, are there any more questions? Okay, well, if there are no more questions, then we'll continue moving on. The first example that we're going to go over is an example of cold weather paving. So kind of talking about being able to either increase your construction season, going earlier in the season or going later in the season, and also if a front comes through, you are able to perform at lower temperatures. So this project was done in New York City, New York in December of 2008. The project was 40% wrap, and it used a PG6422. The ground temperature at 7 a.m. was 11.5 degrees Fahrenheit. And when they laid the warm mix behind the screed, the temperature of the mix was 133 degrees Celsius. So using warm mix in this application, you're able to extend that paving season. They generally do not do paving in New York in December. In fact, if anyone's from there, you guys are probably still trying to dig your way out of the latest storm. But this is an example of if the moisture and those elements are cooperating and it's just those cooler temperatures, there's an opportunity to do some cold weather paving. And this is a pretty popular picture here. This is an example of just how cold it was. These are icicles that are actually hanging from the back of the steel wheel compactor during the construction. So it definitely was a cold day out there, and they were still able to get down a quality product. An example of nighttime or long haul paving. This one was done in Texas on I-35, and the mix was hauled 128 kilometers, or multiplied by 0.6, approximately 70 miles or so. and it was a SMA PG 76-22 mixture. The mixing temperature was 150 degrees Celsius, and the laydown temperature was 122 degrees Celsius, which is approximately 252 degrees Fahrenheit. And with this, they got an in-place density of 94%. An example of more cold weather paving and also high altitude. This project was done in I-70 in Colorado. It was up in the mountains, so west of Denver, and they used a 9.5 millimeter nominal maximum aggregate size mix with a PG 58-28 binder, and the altitude was 3,500 meters. And for anyone who's driven on I-70 in central Colorado, there is quite a bit of traffic, quite a bit of truck traffic on there, and they have greater than 50,000 ADTs a day. And they did have to do paving at night because it was a high volume interstate. They were only allowing lane closures during the evening, and at these high altitudes and cold weather, the air temperature was less than 0 degrees Celsius, so it was below 32 degrees Fahrenheit during this night paving. And this is traffic on that highway the day after the first night of paving. So they were able to go in there, close off a couple lanes of traffic, shift that all to the other side of the road, do their paving during the night, and then that next morning they were able to open it up to traffic. And you can see a picture here of 17 months later. You don't see any significant rutting. There's no major distresses here. And as you walk up and down the project, this is pretty representative of the entire project. Another example of long haul distance and a little bit of rain. This is in New Jersey on Interstate I-78. They used a 12.5 millimeter nominal maximum aggregate size, 76-22 SBS modified with 25% wrap. They were able to place 325 tons an hour in light drizzle. So this shows that with those lower temperatures, you know, the light rains don't affect the paving operations as much. Now obviously if you have a heavy rain, that's a different story. But a little bit of moisture isn't quite as obtrusive as it is with that hot mix asphalt. And they had a 1 hour haul time, and they were getting temperatures of 210 degrees Fahrenheit from their material transfer vehicle to the paver. So they did have an MTV on site to put the mix into from the trucks and then mix it up and then put it through the paver. And here's an example. On this project they were actually doing both warm mix asphalt and traditional hot mix asphalt. And you can see that picture on the upper left hand side. There's no visual fumes from that warm mix, but on the lower right hand side you're seeing more of those fumes. And because there's a light drizzle, some of that may have been to the moisture hitting the ground as well. But that's another advantage when you're doing paving. You don't want a whole bunch of steam in the air. That could reduce visibility for traffic going by the construction site. Now up in Illinois, this is an example of a high wrap content, also including tire rubber. This is on the Chicago Tollway in Illinois, and they used 30% wrap, an SMA mixture with tire rubber included, and they had a compaction temperature of 120 degrees Celsius. So that's a relatively low temperature. And moving on to Texas, an example of a high quality mixture. And we have a question here, so I'll hop back a slide and take time for this question. The question is, which technology is the best for use of high wrap mixtures? Well, I think depending on who you ask, you would probably get very, very different answers on which technology is the best. And I think that there's a couple things that you would want to do when asking that question. The first is understanding which technology would best match the system that you have. So for example, if you have a plant that's hard to modify, that would eliminate, for example, the foaming opportunity, versus, you know, if you were not interested in putting an additive into the mix, that would eliminate the wax technology. But at this point, I have not seen any studies that say when you're using those higher wrap mixtures, certain technologies are better than others. And so to answer your question, I don't know which one is the best, but I don't know if there is a best. So that's something that, you know, probably should be looked into, because when you start changing these different variables, whether it's high wrap, whether you're including tire rubber, or you know, recycled asphalt shingles in these mixtures, maybe some technologies do work better than others. And I guess the best advice I could give at this point is, I know a lot of these manufacturers are eager to get their products out there, so you can call them for a small sample and maybe try and do some work in your lab. You know, run a couple tests, compare a couple different technologies, and maybe go with what's working for you. So I know that's not a very clear answer, but I don't think there is a clear one at this point. But thank you for the question. So an example of a high quality mixture, and this is in Texas, and this actually won an award, which we'll talk about on the next slide. It's the BU-287 in Texas. It's a PG76-22 surface mix. They used two 13-ton steel wheel compactors in vibratory mode, and they did not need to use a pneumatic roller because their target density was achieved with only those steel compactors. So this is an example of a project where traditionally they would be using a pneumatic roller, but because of the ease of compaction, they were able to eliminate or remove that from the job, saving both equipment costs and also labor costs. And this is a high quality mixture because it won the National Asphalt Pavement Association Quality Construction Award. So NAPA goes around every year and gives these awards out, and this project was selected overall based on its positive merits for this Quality Construction Award. So before I go on to the airport example, does anyone have any questions about the pavement side of things? Thank you for asking them as we went along, but I want to make sure that everyone's up to speed. All right, well, moving on to the airport example. I'm kind of an airport nut, so I had a lot of time putting together, a lot of fun putting together this part of the presentation. A very nice example of warm mix asphalt being used at airports was in Boston, Massachusetts at Logan International Airport. And this was the first airport in the U.S. to use warm mix asphalt. And there were actually two different projects that they used warm mix asphalt. The first phase, which we'll go into more detail, was in 2008, and that was on runway 4R 22L. And that was so successful that they decided to do a second project in 2009 on 9R 27L, which you can see in the picture there. Now, although this is the first project that was done in the United States, warm mix asphalt has also been used on airports in Africa, South America, and I apologize for that typo, South America, and in Europe, particularly at Frankfurt, which is another large international airport. So the first project, runway 4R 22L, was done in September and October of 2008 at a cost of $6.3 million US. They used 18% rep, and for this first project they simply milled the outer 11.4 meters and repaved it. So just like highways, which a lot of us I'm sure work on, runways also have shoulders, and this is areas kind of outside of where they expect the airplane to land. So the outer edges, of course, can handle a landing airplane, but they're not used nearly as frequently as that intersection, the inner section of the runway. And this project was approximately 3 kilometers long. It used the FAA P401 mix design, and the FAA is this is a really nice example of using this new technology and using existing specifications. And I think that as we learn more about warm mix asphalt, we will be able to maybe make some recommendations on those specifications, but we are getting projects completed using existing specifications. Yes, Alex, you have a question? I believe that the question is, do you know if the P401 mix design procedure is based on a Marshall mix design or a SuperPave mix design? I believe it is based on the Marshall mix design. Now, if we have any people who are more familiar with the 401 mix design, you are free to jump in here. Just please raise your hand. But I believe it is based on the Marshall mix design. Okay, thanks, Alex. And then Andy's got a question too. Okay, so thank you, Andy. That's he states that he used P401 with the Marshall mix design at a small airport in southern Arizona. So it does appear that the Marshall mix design is used in P401. Thank you. I appreciate that. A little bit about the mix design for the runway. They had a 64-28 liquid base binder. They did have a lime additive to prevent stripping. They also had a latex additive to prevent rutting. And the process they went through is they milled the top 20 centimeters of the shoulders of the runway, and they then put down a 14-centimeter coarse base and a 6-centimeter surface base. And they had to complete 3 passes, 3 longitudinal passes for each side of the project. Now, as I mentioned, because that project was so successful, they also did a second runway, and this was the full width, the full 46 meters, or approximately 150 feet width of the runway. And this was done in 2009 from July to September at a cost of $12.5 million. They used 20% wrap. It's about 2 kilometers long, and they used approximately 26,000 tons of mix. So this is a full-length runway at an international airport. Lots of material being put down, and they've had a lot of success with it. Now, this I found from the press releases from the Logan International Airport. And overall, they saw a 20% reduction in greenhouse emissions, and they saw 20% less energy to produce the mix. The nice thing about having such a large and such a unique project is they're able to really quantify these savings. And you can see for runway 4R22L, they saved approximately 200,000 gallons of diesel fuel. They saved 26.4 billion BTUs of energy, and they reduced the carbon dioxide emissions by approximately 2,000 tons. Now, if you'll notice, the second project was about twice as long, about twice as big. So I shouldn't say twice as long, but they did the full width of the runway. So they saved about double of that, about 400,000 gallons of diesel fuel, 53 billion BTUs of energy, and 4,000 tons of carbon dioxide reduction of emissions. So we went over the background, and we went over some of the types, some field examples, and now we're going to get into the research. So if you guys have any questions, I'd be willing to entertain them now. Yes, Brandon. The question is the environmental monitoring documented in a report? I assume that you mean, was there an actual report published that had these numbers on them? And if that is what you mean, I was not able to find a report with these numbers, and then what I had to do is go back to the press releases. So the Port Authority of Boston actually has a pretty nice web page, and part of that is press releases. So I went back to the 2008-2009 seasons and was able to find press releases that published these. And while that's not like a technical report per se, I do believe that since it was a press release, that's a good enough source for me. But I was not able to find a technical report with this data. Are there any other questions? So moving a little on to the research. Now, I want to remind you that this PowerPoint presentation will be available as a PDF format on the website, and you can also re-listen to this presentation, so you don't need to write all this down. This will be posted online. But if you're interested in the research side of Warm Mix Asphalt, there are countless articles in both Transportation Research Board, the TRR, Transportation Research Record publication, and also the Association of Asphalt Pavement Technologists. Now, I realize as working at a university, I may have access that not everyone has to reports like this. So I also found some reports that are online, and they're available free of charge. And one excellent source is the National Center for Asphalt Technology, or NCAT, and their website is simply ncat.us. They did 3 different evaluations. One was an ASPHA-Min zeolite, so that's a foaming process. One was for Sasabit, which is a wax process, and one was for Evotherm, which is a chemical process. And they did an evaluation of these different technologies in Warm Mix Asphalt. And the report numbers are 0504, 0506, and then 0602. And these are very nice reports. They give a broad picture of what these technologies are. They go through the mix design and then sit through some performance testing. So NCAT always puts out very nice work. So I encourage you to take a look at those if you're interested in those technologies in particular. And they also put out a 4th report about a field trial in 2009 up in Ohio. And this is more of a construction summary. So if you're more interested in the construction side of things, this report has a lot of good information on there. Also, I had mentioned earlier the National Cooperative Highway Research Program, or NCHRP. They put out multiple reports, mixed design practices, some engineering properties, emissions and fuel performance, properties and performance of Warm Mix Asphalt, and then long-term field performance of Warm Mix Asphalt. These are all different projects that have either been completed or are in the process of being completed that have to do with Warm Mix. So if you go to the URL right there, that's the or you can just Google NCHRP National Cooperative Highway Research Program and find these reports. The projects that are done, for example, the mixed design practices for Warm Mix Asphalt, that's posted as a PDF file online. You can read about that. I do believe the other 3 are still in progress, but keep an eye out for those over the next couple months, maybe into next year when those are posted. A lot of these national level projects are starting to come out, and those will be excellent resources to find more information. So getting a little more into the hard research side of things, one of the concerns of Warm Mix Asphalt is because if you're using these lower temperatures, is it more susceptible to cracking? Well, the University of Illinois has developed a fracture test. This is the Disc-Shaped Compact Tension Test, or DCT test, and you can measure fracture resistance of asphalt mixtures. And how this is done is the sample is literally pulled apart, and you're able to capture the load and the displacement achieved. And from those 2 quantities, you can figure out how much energy is required to pull that asphalt apart and to make those new cracked surfaces. And one of the ways you can quantify that is through what's called fracture energy. And again, this fracture energy is just a measure of essentially how much energy is required to make those new surfaces and to pull that sample apart. You can see here they did a range of testing temperatures, -10, -20, and -30 degrees Celsius. So how does this change as you get these colder temperatures? And you can see that the warm mix asphalt, which was, I believe these are compaction temperatures, the warm mix asphalt was about 35 degrees cooler than the hot mix asphalt, but you still saw that 20 to 40% better performance in cracking. And we believe this is because of the reduced asphalt cement oxidation. So as asphalt cement goes through a hot mix plant, it obviously needs to get heated up to very warm temperatures. And when it gets heated up, it actually starts oxidizing a little bit. So all of that heat, all of that oxygen in the area, it forces oxygen into the asphalt cement, which is called oxidation. And the problem with oxidation is it makes a stiffer asphalt cement binder. So when you mix that with the aggregates and put it in the field, your pavement is already a little aged, because then as time progresses it continues to oxidize and it gets more stiff. But if you can save some of that oxidation in the very first step, then your pavement will hopefully last longer. Another test that you may be familiar with is the overlay tester, and this was developed at the Texas Transportation Institute. And this is where you simply glue asphalt sample to metal plates, as seen in that picture, and the plates move in and out. So this is a complete horizontal direction. There's no vertical movement. The sample just moves, the plates just move in and out. And what that does is it simulates the rigid base layers of a pavement structure. So we know that if you put an asphalt overlay on top of Portland cement concrete and you have that Portland cement concrete slab, that slab will expand and contract. And as that expands and contracts, if you have the proper bond between the Portland cement concrete and the asphalt cement, or excuse me, the asphalt concrete, then that asphalt will be literally pulled and then pushed back into place as that Portland cement concrete slab expands and contracts. So this is a nice test to try and simulate that. And the overlay test results, they do the number of cycles to failure, so they essentially pull that sample in and out until it fails. And you can see that the traditional hot mix asphalt had a mean of 58 with a range of 30 to about 110, whereas the warm mix asphalt had a mean of about 600 with a range of 300 to approximately 800. So some people have talked about the overlay tester as having quite a bit of variability, and you can see that in this plot here. But even with that variability taken into account, if they had done a little statistical analysis on this, I think that the 58 and the 600 are statistically different. So you see a statistical increase on the number of cycles of failure, which is a prediction of then what happens in the field. So as a summary of warm mix asphalt, you do get those lower production and construction temperatures. You can extend your paving season, and what we've seen so far is that you get equal or better performance than the traditional hot mix asphalt, both in the laboratory and the field. And I truly believe that from highways to airports, warm mix asphalt is the future of pavements. So I'll take some questions in a minute, but if you allow me to first go to the wrap-up slide, then I'll go back and we can start taking questions. The professional development hours will be emailed to you. I've been keeping track of who's logged in, so I'll try and get those out early this afternoon. If you do not get your development hours for some reason, please just email me and I'll get them to you as soon as possible, but you should see those later this afternoon. You can re-watch the Pavinar through the website, pavinars.uark.edu, or if you want, you can also download the presentation that I gave in a PDF file. And please, if you have some topic suggestions, if any particular part of this topic was interesting, if you go back and look at some of the previous topics and say, you know, it was a little broad, I'd like to go more in depth, please submit those ideas via the website. I'm putting together next spring's schedule. So this is for you out there, whether you're in industry, whether you're at the government or in academia. I'd like to serve what you guys are interested in. So please submit those topics, and we can hopefully get some of those on the slate for next spring. And the next Pavinar will be Tuesday, December 6th, and I'll be answering the question, what is mechanistic empirical? So we have the mechanistic empirical design guide, now called the Darwin ME, but what does the term mechanistic empirical mean, and how is that used in our industry? So thank you all for attending. I encourage you to stick around, and I will be happy to answer any questions that you may have. But thank you very much. All right, well, I don't see any questions. Therefore, thank you. Oh, I spoke too quick. Thank you very much. Andy, you've got a question? So Andy's question is, do you know what the differences are between a chemical warm mix asphalt technology and a straight up cold mix emulsion? And that is a very good question. So Andy, if you allow me here to scroll back to this slide right here. So if I'm understanding your question correctly, you're saying that cold mix emulsion has been around for a while. And cold mix emulsion is often used for if you have a stockpile of material, you need to fill potholes during the winter, or you may have a small project, you could use what we consider cold mixed emulsion. And is that different than a chemical warm mix asphalt technology? And I believe it is, because these chemical warm mix asphalt technologies are meant to go through what we kind of consider a hot mix asphalt plant. So they're put into the liquid asphalt binder, and then that binder is fed into either the drum or the pug mill if you're in a batch plant, but usually into the drum of a continuous plant mix. And I think that technology is quite a different versus the concepts that are used in a cold mix emulsion, which is where you have an emulsion off-site and you can simply take some wrap, mix it with that emulsion, and then stockpile that. And that can be stockpiled and used for, you know, a couple days, a couple weeks, depending on what kind of material you have. But I think the chemical warm mix technologies are advancing rapidly. And I think that they're advancing with the understanding that they'll be put through a hot mix asphalt plant, and how can we really maximize that drop in production and construction temperature, and how can we still maximize the construction techniques and also the performance of the mix. Well, yeah, thank you for the question. I know it's kind of long-winded, but and also if people, I don't pretend to be the know-all expert in these subjects. If you also have something to add to one of the answers that I give, please simply raise your hand and you can type it in the chat box, because I know a lot of you have expertises that I'm not familiar with. So I would welcome participation from the group. So are there any other questions? Okay, well, thank you very much. Again, I encourage you to join us next month on Tuesday, December 6th at the same time. I just say 12 Central. I know there's daylight and standard, but quite honestly, I can never remember which one we're in, so I just always say 12 Central, and I trust that people can plan accordingly. But thank you very much for participating, and I'll get those PDHs out. Have a nice afternoon.